Hello and welcome to Unit 2, Lesson 2, Part 1. So this lesson is broken up into several different parts, which should make the concepts a little bit more bite-sized for you, and we're not going to be taking on too much material in one lesson, which should give us a chance to digest that material and really get comfortable with it before moving on. So to begin with, and you might need to pause the video here if you're taking notes from home, is we have a summary chart here. So on the left-hand side, we've got the name of the form. So we are starting a unit on quadratics. We started that last lesson. And when we're talking about quadratics, there are actually three forms that the equation can take. And so that's what we have going down the left-hand column. In the middle, I'll give you like the formula, what that form shows us, and then, or looks like, and then in the far right-hand column, what it shows us. So what do we learn from that particular form? So if you are taking notes at home, you might want to pause the video and get that chart set up in your notebooks before we go on. So the first form is vertex form, and this is going to be the emphasis of today's lesson. So vertex form looks something like this. It's y equals or f of x equals a, and then a would be multiplying, and then we have in the parentheses x minus h, all squared, and then plus k. Now that probably looks familiar to you. If it does not look familiar to you at all, then I strongly recommend going back to the previous lesson, because when we were studying transformations on quadratics, this was the form that we were building. And if you go back to the last video, I was actually using h's and k's in that video in order to prepare you for seeing this. So this is vertex form. That's the general form. You've got your x and your y, which of course you might have f of x instead of a y. And then the a, the h, and the k all represent numbers. Okay, so they are numbers that you might see there, and then your x and your y would be your variables. What does vertex form show us? Well, don't overthink this. Vertex form shows us the vertex. It is also the form that would show us the transformations most easily. Give me a second to write that in there. And by that, what we mean is the left, the right, the up, the down, whether or not it is flipped, whether it's dilated, meaning it is stretching or compressing, and so forth. So your vertex form is the form where you can most easily see those transformations. Factored form looks something like this. Y equals a, so you would still have that number out in front, and it actually still performs the same function. So it would still tell you whether the parabola was stretched or compressed. You guys can't see my hand. I don't even know where my hand is. There we go. Stretched or compressed. And it would also tell you whether or not the parabola was flipped over. But it would look like this. Oh, sorry, I'm doing the wrong form here. Don't write that down. Here we go. X minus P times X minus Q. And we use P and Q there. You can really use any variable, any letters there that you want. They represent numbers, but P and Q is what we've settled on. So A is actually the same value that you have in the vertex formula, and it does the same function. And then P and Q would just be numbers. And we call this factored form because factors are things that are multiplied together. And you can tell that this form actually has three factors to it. It's got a factor of A, which is multiplying a factor of x minus p. The entire x minus p is a factor. And then the third factor is x minus q. And so it's called factored form because it is written in a form so that the three factors are being multiplied together. What does this tell us? Well, typically factored form is good for telling us the x-intercepts. And we will get into that in a future lesson when we study factored form. Why does factored form tell us the x-intercepts? Now, just for vocabulary, the x-intercepts are also known as zeros and roots. And so those are completely synonymous. zeros, roots, and x-intercepts. I guess I shouldn't say completely synonymous, because zeros and roots can be what are called complex, and I don't want to get too far in the weeds with that, but for now, you can think of those as being the same thing. And if you were asked for the x-intercepts, what you're being asked for are the zeros or the roots. And then finally, we have the last form. This is standard form. This is a form you might be familiar with from Algebra 1. And this also starts off with an A. It is the same value, and it performs the same function. So the A value is consistent throughout all three forms. And we have y equals ax squared plus bx plus c. And that is called standard form because it is written in the order of decreasing exponents. So you'd start with your highest exponent, which in a quadratic is a 2, and then you go down to your next highest exponent, which would be a 1. That would be x to the first power. And then attached to the c here is actually x to the 0 power. So I'm trying to do that with the little laser pointer thing. X to the 0 power. We haven't really talked about what it means to have a 0 power, but and then A, B, and C would just be number values. What does standard form tell us? Like, it tells us, what does it tell us? It tells us the y-intercept. We can get the y-intercept off of standard form. And it also, that's supposed to be a P. Y-intercept. And it also tells us something called the end behavior, which is what the parabola does at the ends. Like, does it point up at the ends? Does it point down at the ends? Okay, and it does that by telling us the flip on it, which way it's flipped. So I just want to include end behavior in there because when we get to unit 4, which is higher order polynomials, that end behavior becomes more important when you start changing what the exponent is. So that's our table. So we've got the different forms and then what those forms are good for showing us. And if you haven't, please take a moment, pause the video, and copy that down. Okay, so key skills for today's lesson. So by the time you are done with this video, what should you be ready to do? Let's find out. So you should be able to sketch quick graphs from Vertex form. Many graphs do not need to be super accurate. And you might think, oh, that's kind of weird. Like we've always been really particular about what the points are. Yes and no. So we use certain key points. So there are certain really, really important points that we want to get correct when we're doing a graph. But we use those key points to get a general idea of how the function behaves. Remember that the graph is the picture of the solutions. It's a picture of what the solutions look like and the patterns that are involved in it. And so a lot of times we don't need our graphs to be super, super accurate. We just need them to be accurate enough to be able to get the information off them that we want. If we need a graph that is super, super, super accurate, then we would use Desmos or a graphing utility, a calculator of some sort. And we want to be able to use that graph to state the following. The vertex, so this will be a review of the last lesson. We actually did a lot of this in the last lesson, so this makes today much easier. If you did not watch the last lesson or you were absent from class, please go back and watch that. Okay, please go back and watch that material. The axis of symmetry, which I abbreviate AOS, I kind of meant for that S to be capitalized on the AOS, but I use AOS to abbreviate axis of symmetry. I have seen curricula that just say the axis, which to me feels a little bit vague. So I talk about the axis of symmetry. The minimum or maximum value, as opposed to the minimum and maximum itself. So we'll get into that on this next slide. So key vocabulary. So in your notebooks, you got that big chart. Now you want to write down your key vocabulary definitions. Okay, so that should be the next thing going in there. What is the minimum maximum value? Well, the minimum or maximum value is the lowest or highest. Okay, there's your minimum and maximum. So minimum would be the lowest, maximum is the highest y value that the function reaches. And if you don't want to put the word function in there, you can say parabola, but We'll go with function. Okay, so it's the lowest or highest y value that the function reaches or the parabola reaches. Now, this would be as opposed to just the maximum or minimum, which would be the entire ordered pair. So, for example, if you follow along with what I'm saying here, we might say that the maximum is 3, 6, which would be the entire ordered pair, okay, meaning that is the point where the parabola reaches the maximum value, and the maximum value is y equals 6. Okay, so the maximum is 3, 6, and the maximum value is 6. And the key thing you want to take away from this is that when we're talking about the minimum and maximum, we're talking about y values, not x values. Okay, y values. And so you might want to box that in, highlight it, star it in your notes, so forth, so forth. The y value tells us what the minimum or maximum value is. The x value tells us where the minimum or maximum is. So you've got a what and you have a where. And this has to do with the definition of function. Each x maps to only one y. And what that means is that you can use your x coordinates to locate where you are on the function. And then the y value is what is the value of the function at that point. And so your y value is what the minimum and maximum is. The x value is where the minimum and maximum is. Let's do an example. So here we have a lovely example here. We have y equals negative x plus 3 all squared plus 2. And you can notice how I said that. I put the word all in there, and that indicates the presence of the parentheses. So negative, and there's like a pause when we say it. Negative x plus 3 all squared plus 2. If you just say negative x plus 3 squared plus 2, it kind of runs together and it could be a lot of different things. If you want to be really clear when you're talking out loud, you would say negative in parentheses x plus 3 all squared 2 plus, or all squared plus 2 outside the parentheses. And so we would get really, really clear with it. So here's how I would approach this problem. So I'm asked to state the vertex, the axis of symmetry, the minimum and the maximum, and the minimum maximum value. Okay, we just want to make that distinction between minimum and maximum being the point and the minimum maximum value, which is the y coordinate. So to do this, I am going to note my transformations. So this is a review from the last lesson. That negative is going to flip the parabola over. The plus 3 means that it is going to slide left 3, and the plus 2 means it is going to go up 2. That again is a review. So what I'm going to do on this graph over here to the right is I am going to do a quick sketch. So I am going to go left 1, 2, 3 and up 2. You probably can't see my pointer. Maybe you can though. There's my vertex right there. Here, let me make a point. There we go. Right. It's supposed to be right there. If I do that with my finger, it's going to get messed up though. Yep. And then it is flipped over. So it would look something like that. And that point again is supposed to be at negative 3, positive 2, left 3, up 2. Now, once you have your quick sketch, the rest of this is actually pretty fast. So what is the vertex? Well, all I need to go is locate it on the graph there. It is at the point negative 3, positive 2, because it went left 3, up 2. The axis of symmetry is the vertical line that goes through the center of the parabola. So what I'm going to do in a different color is I'm going to highlight my axis of symmetry. So I want you to notice a couple of things about how I did that. One, I did change the color because I want to distinguish it from the actual parabola. Typically, students are not writing with more than one color, although some of you do. So students will opt to do the axis of symmetry very faintly. So they'll find somewhere like the parabola is dark and the axis of symmetry is lighter. The other thing you can do, and what you should do, is make it dashed. And this is something that comes up in my engineering classes. We talk about things called construction lines, and they are lines that are used to build a design, but they are not actually part of the design themselves. And I often mention axis of symmetry when I do that the axis of symmetry is not part of the parabola, but it is a feature of the parabola. It anchors it, and it anchors that symmetry. So the axis of symmetry is a vertical line, and it goes through the center of the parabola so that the parabola is symmetrical on either side of it. So the axis of symmetry, because it is a vertical line, it has undefined slope, and undefined slope, it means it's not defined. Kind of started a sentence there with no plan on finishing it. When you're writing the axis of symmetry, you need to write the equation of the line, and that means you will need to write x equals -3. That is the equation of the vertical line. Now, before we move on, I want that to make sense to you. Okay, I don't want you just saying, okay, when I write the axis of symmetry, I have to write x equals. Here's why. You're looking for the equation of that line. If you pick any point on that line, okay, like say that point right there, if you look at where my laser pointer is, what are the coordinates of that point? That point, it would be -3, 5. If I go here to the vertex, it is -3, 2. If I go right here, it is -3, 0. If I go down here, it is -3, -5. And what all those points have in common is that x is equal to -3 in all of those cases. So if you wanted to graph the entire line, basically it doesn't matter what the y coordinate is. The x coordinate is -3. And so the equation for the line is x equals -3. It is not a function because all of the points are stacked on top of each other. You've got one x value, and it goes to an infinite number of y values. So it is definitely not a function. If you only write -3 for your axis of symmetry, you will force me to have to take off something for notation. Okay, so please be mindful of that. The minimum maximum point is the vertex. Okay, so it would be -3, 2. So in these problems, the minimum maximum is the vertex. That will not always be the case. Okay, we will look at more complicated functions where they're not necessarily the same thing. And so I want you to get used to that verbiage there. And the minimum maximum value is y equals, and remember your minimum maximum value is whatever the y is. And in this case, the minimum maximum value is y is equal to 2. When you do this, for me, I do want you to circle or write out whether or not we're talking about a minimum or a maximum. And in this particular parabola, because the vertex is at the top, it represents the maximum or the highest value that the y could be. So I know I was on that slide for a little bit longer than I intended. I wanted to make sure that we got all the questions answered and we're not doing anything on that screen that you don't understand. So if you need to go back and rewind it and listen to it again, maybe twice as fast, but at least get the explanation again, please do that before you move on to the next slide. All right, this next one, we're going to do it the same way. We'll do this one a lot faster, okay? So I got a lot of the explanation out in that first one. In this one, reviewing our transformations, this parabola is going to go right 4, and that's it. That's the only transformation on there. So we don't have any flip, we don't have any dilation, we don't have any up or down, and don't make there be one if there is. So I'm trying to get my cursor over there. It's supposed to be at like going right 4, but and not having a lot of luck with that. My upstairs neighbors seem to have gotten a large dog, and probably you can't hear it in the video, but There's like loud animal noises coming from above me. All right. And that is not the greatest job I've ever done, but okay. So there's my vertex, and we're going to put the arrows on the parabola indicating that it keeps going up. And so it takes the parent graph and we just slide it right forward. So what is the vertex? Well, the vertex is 4, 0. So it goes right forward, but it does not go up at all. The axis of symmetry is the vertical line going right down the middle. And so if you look at every single point on that line, what do they all have in common? Well, they all have in common that x is equal to 4. So you do need to make sure that you state the axis of symmetry as x equals 4. In this case, we're dealing with a minimum. So the minimum point on that green parabola there is 4, 0. So it will be the same as the vertex. And in this case, the minimum value, or the lowest point that the parabola reaches, would be y is equal to 0. And I will be picky about your notation on this. So you do need to write x equals, you need to write y equals. Those things need to be consistent. If you just give me a number value, I have to take off something because it's not 100% correct. So we have a couple practice problems. If you are watching this video from home, at this point, pause the video and go ahead and do these practice problems on your own. And then you can unpause the video and come back and join us. Okay, so probably from your perspective, all this writing just appeared on the screen. So quickly we can go through this. So the transformations on this first one are right 2 and down 3. And so that's where I located my vertex, and that's where I did my quick sketch. Right 2 down 3. Right 2 down 3 means that my vertex is located at 2, -3. The axis of symmetry running down the middle right there would be on x is equal to 2 because the vertex is on the axis of symmetry. The minimum value in this case would be the vertex, or sorry, the minimum, not the minimum value, would be the vertex at 2, -3. The minimum value is y equals -3. It means that's the lowest that parabola goes down. Over here, our transformations are a flip. It goes left 3 and down 2. So we go left 3, down 2, and we draw it as flipped. The axis of symmetry would be that vertical line on x is equal to -3. The maximum is the point -3, -2, same as the vertex, so -3, -2, and the maximum value would be y is equal to -2, meaning that it gets up all the way up on the y-axis up to a -2, but not any higher. So if you made mistakes, practice problems are totally okay to make mistakes on practice problems, but notice what you did. Notice what kinds of mistakes you made. Did you make notation errors where you just said, oh, -3 instead of x equals -3? Did you go like left when you should have gone right? Like that kind of thing. Notice those mistakes and take a moment now to correct those mistakes so that we can reinforce the right way to do it. And that brings us to the end of the lesson. So for your homework, for problems 1 through 3, do a quick sketch of the parabola as shown in the lesson. So all I want you to do is like the sketch, just the sketch. For numbers 4 through 6, state the vertex, axis of symmetry, minimum and maximum point, minimum, maximum value. Be sure to indicate whether it is a minimum or a maximum. So 4 through 6, just like what we just did. For number 7, check your answers on Desmos and make any corrections. So if you are doing the quick sketches of the parabola, what I want you to do is go on to Desmos and graph them on Desmos and make sure that the Desmos graph and your graph actually match up. If they don't, okay, you want to make your corrections. If you think yours is correct and you think Desmos is giving you the wrong graph, then absolutely you're going to put that into number 8. What questions do you have about this topic? Because if you are sure that you did your graph correctly and Desmos is showing you something different, then it's possible that you're typing something into Desmos and you're using like the wrong key to type it in, and we absolutely want to get that straightened out. Or if you're making a mistake in your own work and Desmos is right, then we need to identify that as well so that we can leverage Desmos for everything it's worth. All right, so 25 minutes, that's lesson 2A. And as always, let me know if you have questions.